Welcome back, everyone, to another coffee session. This has been a huge week for us. We are so lucky to be graced by the presence of my man Ketan Umar.
My God.
And
Great.
he is here with us to talk about Flyte today. You know, we are rolling with the usual Bam Bam. I myself am Meech, aka
I'm out
Demetrius
here.
Brinkman.
And I'm David Aponte.
Yep, he's working
And I'm
machine
Ketan.
learning, and Ketan is with us. So we are going to talk a lot about this whole machine learning infrastructure that they've got going on at Lyft that is named Flyte. They open sourced it about 9 months ago, and Ketan is the lead engineer, the lead machine learning platform dude for all of that.
He's the
So
guy.
yeah, man, and it's
He's
it's
just that
amazing that
guy.
you're here with us. I
Kind of
appreciate it
scary
because
now.
well, let's just do this. Let's say this. He's only done two other podcasts, and one was Twimmel, and the other was Software Engineering Daily. So I don't know
There you go.
if we're gonna live up to either of those, but at least he's here joining us.
That's right.
This sounds the most fun one. Sorry, Sam and Jeff. Don't feel bad about it.
I don't know. I don't think they listen to this, so it's all good. But in case they do, yeah, no worries. No hard feelings, no shots fired. Now, let's get into it, man. I know we got a lot to talk about. I wanted to
Yep.
just start with like a little introduction with you, Ketan. Can you tell
Yeah.
us about yourself, how you came to be in the lead position for the ML infrastructure at Lyft?
Oh yeah, it's complete happenstance or coincidental. I don't have specific background in machine learning. I'm an engineer by training. Started my undergrad 15 years ago. Worked out of there. Worked on banking and anti-money laundering system. So did some machine learning there. Realized I know
Nice.
nothing. Right, I really did not know anything, and I was like, "Oh my god, I need to learn more." So that's when I went and did my master's from Georgia Tech. At that point, machine learning was very different. So I kind of gravitated towards high performance computing and the distributed systems part of it. Yeah, I used to work on CUDA before it was cool. So that's what
And
I
what
say
drew
you should.
one question, what drew you to those particular things? Why were you interested in distributed computing? Like was it just the scale of things, the
Yeah.
difficulty, the challenges of the problem?
So when I was working on the banking and the anti-money laundering systems, we were actually running a lot of algorithms, and the problem was not the algorithm, right? I could write the algorithm. The problem was just the amount of data that we had and how quickly we wanted to simulate it and produce results. And we were writing all of this in C++. This is like 2006, right? It's completely different world. Yeah, and so when I started thinking about it, the problem was how do I make this efficient and how do I make this quick and really deployable for in production. And so the challenges and I saw that the world was going to move a little more away from one. At that time, we still had one large machine, right? You just scale it upward
Ah,
as much as you
Yeah.
can,
Vertical
and we were like,
scaling, right?
yeah, and we were
Or
slowly moving away.
CPU.
Yes, and large databases, pay 100K for a database or something, and then yeah, it's crazy. But yeah, it was moving away. So I was like, oh, this new world, I'm probably not ready for. I had done some distributed systems courses. Let me just go and understand more and see what I can learn. Um, yeah, so that's when I went to Georgia Tech. Yeah, as I said, worked on CUDA. I wrote some of the kubla stuff initially before it was cool. This is 2007, 8. Uh, and then worked at some high frequency trading stuff. I went to Amazon, worked on their logistics, like lots of V0s, Amazon Fresh and Locker and all of those other like their warehouse transfers. So the Amazon's like this huge giant today. In 2008, 9, they were building the groundwork. They were laying the groundwork for becoming the large giant that
oh,
they
that's
are
fascinating.
in logistics.
Nice.
And I was part of that team in the beginning. And then later on at Amazon, I worked on mapping. Mapping is like just building
Yes.
maps. And so
So
that was the cool part, I think, and that led me into cloud, and then later on into Lyft. So
For those of us,
go
just for
ahead.
those of us who are a little less familiar, what do you mean by map? Are you talking about like MapReduce, like
Yeah,
or is this something different?
no, like Google Maps.
Oh, Google Maps.
Yeah,
Okay,
like
got you.
maps, like and I think it's in my varied set of problems that I worked on. My favorite is mapping. It's just amazing.
That's a
It's like
hard
this.
problem. Yeah,
It is like,
that's really hard.
and there's a funny story. Like when I this was part of Fire Phone, and at Amazon, people there were some
That
engineers that
definitely.
were
That's the one
selected
that
into.
failed, right?
Yes, there were some engineers who were selected or whatever, elected or put onto the Fire Phone team, and I didn't know what I was joining. It was a secret, even for the engineers. And when I joined, I'm like, oh my god, the Fire Phone. But I was told, hey, by the way, you'll work on maps. And I'm like, oh my god, that's even crazier. I have no idea what maps is. So we actually started wire sharking Google Maps. I shouldn't say this out probably here,
Sorry,
but
we cut that out. We can cut that out.
yeah, that's fine. That's fine. No, it's just like that's how we learned about what maps is. Like there are these tiles that float, and they're put together somehow to build a map on the phone. It's amazing. And from there to actually building a fully rendered map, like not only raster, right, vector rendered, so with 3D buildings. For the Fire Phone, we wanted all the 3D technology with like head tilting and all that to work together.
Oh yeah.
And that and traffic and routing
No
and
way.
search. It's just a fascinating problem.
Yeah, there's so many interesting, like you just there's so many problems that I could think of that are going on there. Like, like the classic like hard algorithms, right, are typically like the travel salesman, these really hard problems to solve. And I think that's super fascinating. I like that you like that complexity. That's cool.
Oh yeah, traveling salesman was the Amazon has an implementation of traveling salesperson. That was me initially, like a long time ago,
Oh, that's
2009,
so
10 maybe.
cool.
Yeah. So yeah, and then from there worked on Oracle Bare Metal Cloud. So this is like Oracle's attempt to build another cloud. Which started in Seattle, and I think I was one of the first few engineers on that team that started building it. And Lyft came along knocking, and they talked about mapping again. And I was like, I had this itch to scratch again. Like I had to finish that stuff. So I moved to Lyft. First things that I worked on at Lyft was like, if you remember, I don't know, you guys are not in the United States, but or are you, David?
I am. Yeah, I'm in New York. Yeah,
So
brother.
yeah, so if you use Lyft, right, 4 years ago, the cars used to spin. That was my first contribution to move away from that spinning and make it a little more boring, follow the roads. And so yeah, so that was 5 years ago now, close to. And then I've been continued the journey, and we can talk more about like the
That's
history
so
about.
awesome. Yeah, that's such a fascinating story. Lots of interest. Honestly, you dealt with some really hard problems. So it makes sense how that kind of all coalesced and gave you a lot of background experience for Lyft, because to me in my mind, like that, it's a hard problem, right? Like it's everyone's using it. There's so many things going on. It needs to, like, the service level agreements are probably very maybe rigorous because of how much traffic you're dealing with, the scale of those things, man. Yeah, I think there's a lot that we could talk about there.
Yeah, and the thing is, everything's real time, moving quick, right? It's like, for me, Lyft is like a marketplace, like Amazon, but very unlike Amazon, because the inventory is moving around. The cars are just moving around, and you're like, oh, it was there 1 second ago, now it's here, and the demand is moving around, right? And so, an example that I gave is Airbnb is an awesome company, it's amazing work, but their customer interactions very, slow as compared to Lyft. Like the customer interaction with Lyft is like happening twice a day potentially, like for commute. For Airbnb, you think mostly for travel purposes, which doesn't happen every day. It happens like less frequently.
Yeah, that's
And so the
right. Yep,
problem
yep, yep.
scale changes, right? Yeah. According to me, Lyft and Uber, outside of the big five, in the tech firm, have like the most varied set of problems
Yeah.
because of the business. Now that's a big challenge, but so it does offer to build a different and interesting solutions to those problems.
That leads me right into one of our first questions that we have is what sort of requirements does Lyft have from a machine learning infrastructure point of view?
Mm.
What what are your needs? And again, you could whatever you can disclose.
Yeah, and I'm sure I'll get it wrong. So because this like it's varied, as I said, right? So on one end of the spectrum, we have marketplace teams, which are the things that make Lyft work. This includes locations, the data that's ingested, ETA, which is the reference between 2 points, right? And then dispatch systems and pricing. So these together form marketplace, and there are a couple other smaller teams over there like forecasting and so on. From there, you move into the core foundational technology for all of this, which is mapping, to be
Ah,
honest.
that's right.
And
That's right.
so
Right.
there's a lot of mapping. And then from there, you move to, by the way, if we have mapping, we have to collect a lot of data for mapping. So we have like vision style stuff where we're collecting live feeds, or we are like trying to understand uh, network using inertial data on the sensors and so on. And from there, if you move further down, there is, or further up, I don't know how you go in the stack, but autonomous, right? Like that's like the other bit.
That's
And
a
along with all of this,
whole problem.
yeah, like most of the other people would be familiar with other sets of problems like fraud and growth. Those exist as well. So now if you see, it's a whole gamut of systems that exist, and they all bring lots of different use cases. There's no archetype for them, but does that mean there are only hard problems? No, there are very, very simple, straightforward problems. You have 100 megabytes of data. You want to train a simple model and deploy it to a service. And sometimes you have terabytes of data, and there is no simple model. You have to
Yeah.
train really big distributed models, and then don't even deploy them. They go to the car. So
So it
yeah.
sounds like it part of the challenge is actually coordinating all of these systems. I mean, you guys sounds like you guys have like a microservices sort of architecture where each team forms their own service with their own requirements. And how do they typically collaborate? Do you guys have your own compute, like your own data centers, or are you guys on the cloud? How does that work? Maybe I don't know anything, so I'm asking.
Yeah, no, we're completely on AWS. We are AWS shop. That way, we are also a Python and Go shop. Interestingly, so Envoy, which was built at Lyft, is another. It's an extremely large open source project now, and it is the core backbone for our microservices
Nice. Okay.
framework.
Okay.
It's a mesh network that we
Yeah. Yeah. Yeah.
use for services to communicate. And actually, the reasons why microservices work is because of organizational scalability, right? It's like,
Yeah. It makes
hey,
sense for
here's
you
my
guys.
yeah, not only like us, like many companies which are growing, right? Like it doesn't make sense for if you have 10 engineers, and probably you should really think about it. Though if you start early with it, it's good, but it also brings a lot of problems like observability, visibility,
Yeah.
change.
Lots of overhead.
Change is
Yeah.
slower and so on sometimes. But it's a great organizational tool. Once you are able to split something by network and have an interface in between, you can put 10 engineers on the one side of the network and 10 engineers on the other side of the network, and they just have to agree on the contract, and you can keep on scaling that way, right? And that's why microservices work. And
Definitely
yeah,
some
so
challenges though, right? Like notifying each other when changes are made, breaking changes. Like there's a lot. It's cultural as well, I imagine, at Lyft, where you guys have to collaborate, not just at like such a technical level, but even how you guys view the work. Would you say that that's true?
that is true. So, but I think we have evolved at a point. I don't want to say completely, but like to a point where we know how to make at least the regular changes to the contracts, right? Like because we use things like protobuffs, and we
Yeah,
use
yeah, nice.
like binary formats that are more amenable to schema evolution and so on, right? So that when we add new things to stuff, they don't break. And these are all learned from the other giants, right? Like we basically, let's say Amazon, Google, Facebook, all of these people have solved these problems in the past. What we found a problem with was how do you get onboarded onto a new service, and that's where Envoy was built. And it's like And how do you give visibility into it, like, and make sure that it's a very consistent way of solving that problem. And Envoy does that beautifully.
So can you talk about the type of scale that you guys are running at? Because I think it was on a blog post that Flyte itself has, what is it? Let me see what the quote was. More than 900,000 workflows executed a month and more than 30 million containers executed a month. That is just unreal.
Yeah. So Flyte has seen its growth, right? Like, so we are still trending upwards, I would say. Everything is a pipeline essentially at some level within the company, right? Like, it's like and definition of pipeline here is loose, right? It's basically saying that you move from some data from A to B to C to D, and going through multiple transformations, and then achieve some end result, which could be a model. And that's why Flyte is a little more general than just machine learning. It can do other stuff.
That's what I was. We're gonna, I guess, talk about that in a little bit. But yeah, it seems like it's more so just like a workflow system. So like maybe if you're interested in that, we could talk about basically, what is that typical flow of information in like what sort of pipelines are you building at Lyft, independent of machine learning? Just like what sort of workflows are you guys typically trying to orchestrate?
Great question. Yeah, I like, so sometimes, so there are about, I'll tell you today, there are about 600 engineers actively using Flyte weekly at Lyft alone. And so I cannot even answer all the various things they do.
Yeah, no worries.
So if I misrepresent them, I'm sorry, guys, but I'll try to cover some of the examples. Like, so Flyte is currently the place where all of Spark at Lyft runs also. Like, so Flyte is not just a workflow engine. It's like a workflow engine combined with the orchestration of the low level infrastructure that makes that bit happen, right? And this is like, we're trying to, let's say, think about it like an Apple, or Apple, the iPhone maker, Apple. So if you vertically integrated things, right? If you vertically integrate things, there are benefits. You can co-locate things. You can make things work in one place and get a lot of advantage of sharing, right? Like, and that when I'm talking about purely infrastructure sharing. So we really don't, like, Flyte doesn't really do the pure infrastructure orchestration. It relies on other services like Kubernetes.
Yeah, exactly.
Or maybe there are some hosted versions like SageMaker, or in some cases it could be Databricks for some other people. But for us, we run Spark natively on Kubernetes at Lyft. And our scale is pretty high even for that. That alone, like, probably 100,000 or maybe 300,000 jobs a month on Flyte, right? So, and they could be doing multiple things. Like, sometimes it's feature engineering, sometimes it's extract ETL style stuff, or sometimes analytics, right? Besides that, machine learning pipelines. So building a model, just like, retraining constantly. Besides that, there are actually some pipelines that are just doing log aggregation and cleaning. It is, it's like just keeping it, making sure there is like no violations in security and so on. All of those things are also run. There are some financial, analytics pipelines, executive dashboards that are powered by Flyte. So it ranges and all, like L5, like we get like so when we have some cars driving around, we collect a lot of data, ground truth data, and then based on that, we train a bunch of models. Not only models, we clean up the images, we resample them. We
all in real time.
No, actually,
some
for
of this is
autonomous.
Offline?
Most of this is like, for autonomous, most of it is offline, because
that makes sense.
okay, right? Yeah, the benefit of offline for autonomous, or for many systems, is it's actually easier to optimize, because you know all the data, so you can probably scale up once quickly and have an optimal algorithm ahead of time. And
versus like on the fly, when you have to do all this stuff, you have to do all this stuff on top of just like getting the information.
And don't get me wrong, there are many real-time systems, but Flyte's actually not on the real-time trajectory. It's only like at a kind of real time, like every 10 minutes or 20-minute type of
Okay.
trajectory.
So batch jobs, it sounds like jobs that need to run in batch. You're not, there's latency is important because obviously you want it to get done within a reasonable amount of time,
Yeah.
but it's more for handling big workloads, it sounds like.
Yes, exactly. Yeah. And again, where you touched upon one thing is like it's a workflow engine. Yeah, that's the core of it. So the engine itself is scalable to milliseconds, seconds eventually, but that's not been our focus, right? Our focus has been the unloved portion of the world, which
Yeah,
is like
yeah,
just the large scale batch jobs and make them serverless. I think the reason why Flyte
yeah.
wins and has 600 people is because they don't think about machines. They write code and hit a button and it scales to their need somewhere. They don't even know. They just get a page only about the failures in their code, not about failures in the machine or like networking issues or none of that. Just completely taken care of.
That's
And
nice,
that's why
man,
people
because
like it.
there's so many. Those are a lot of the problems that I deal with are typically those sorts of things. Like I have to deal with a lot of low level stuff, but it's great that you guys are thinking about extracting that. Now, this maybe actually, Demetrius, maybe you could take this part about the user stories.
Yeah, I just was wondering what the typical user stories you're dealing with at Lyft are.
Yeah, sorry. I think maybe we should have touched it better. But
No worries.
yeah, I think so. Flyte on its own is more general. Machine learning platform deals with specific machine learning use cases like how do you train a model, how do you deploy the model to a service which is not Flyte, right? Something separate. How do you once deployed, how do you make sure that the model is monitored and it's working correctly. And there are other teams like that build on top of Flyte in many cases to achieve these results. On the other side, there are data use cases where you build ETLs and things like that. And on the third side is just engineers building. Like there are some teams that cannot use machine learning platform directly just because of their scale and intricacies and so on.
Okay,
So they
okay.
use Flyte directly to achieve like pricing and ETL. These are big teams and mapping, right? They do some
Nice.
machine learning, but they do a lot of data processing. So that's where like Flyte really fits, and they love using Flyte directly.
One
So
other thing that I wanted to ask is you mentioned, oh yeah, like using Flyte with SageMaker, Databricks potentially. How have you seen it used with other tools?
oh yeah, so maybe I'll give you a little bit of a history on Flyte, I guess.
Yeah.
So I used to lead a team called as ETA models. We were building machine learning models for ETA specifically, and it was a core and very important part of Lyft because that's like how you determine how far is somebody, and based on
Yeah,
that we
it's huge.
dispatch. We do all decisions, right? And it's not like the time, right? It could be something else. It could be like a number, just a number, right? That we want to make sense of. So we started. I started leading that. We had a lot of data. We wanted to build a traffic model that will analyze the road and figure out how much traffic is on the road at the moment, so that we can improve our car dispatches. And so at that point, we didn't have any infrastructure to run it really. And there were a little bit of Spark code. You can think about it. There was some XGBoost. There was some other stuff on it, like some validations that we were running in Python. And so people used to run it directly on the laptop or run from the laptop into our, let's say, the Qubole. We used to use Qubole for running some Spark jobs. And
Nice.
so it was just crazy. We automate, like over a weekend, I automated that to use Airflow. And that was like in 2016, some like late like November or something. And we hacked around Airflow quite a bit. We added parameterization and things like that into Airflow somehow. Don't ask me how.
It's
It was
doable.
a hack.
It's a pain,
It's
but it's
doable.
doable.
You can hack a lot, and it's Python. You can do anything in Python. So we did that, and we got it working somehow. And it was like, cool, this works. We somehow ship it. Let's get the model out. Painfully, I cried through the night when I supported it, but I was laughed through the day when I was like, hey, my team's delivering stuff. That's cool. So we delivered it, and then as successes, right, we we got interest from other teams saying that, hey, can I use what you guys just did to run my model? We're like, hold on. This thing is not ready for building other things. It's a hack.
That's great, man.
And so I wrote like a white paper of some sort, right? Like a 15-page document on what should the system look like, and why it could be built with Airflow. There was no what do you say? It never talked about the actual implementation. It only talked about the what. And so
I
that
like
became,
that.
and people looked at it and people like, holy crap, you can't build this stuff, man. This is like, it's pretty hard. And we are like, we can. And so we started building an interface. We got like a couple months, and what we did is we built an interface that worked on top of Airflow, added all of that stuff,
Damn.
and it worked on something different that would solve those whats somewhat. Not the entire set, but at least like 50% of it. And over the 2 months, we wrote like a service and had a hosted platform and put it out there. One team, pricing, which is a very big team, had not delivered a model for a little bit. So they pinged us and they're like, we will use this. Like, okay, cool. It's awesome. You guys are crazy and we are crazy too. So, as we took the PagerDuty, we supported, and it was built on top of Step Functions, which is a hosted AWS service to do workflows, AWS Batch, and some little bit of Kubernetes thrown in there early. Think about this 2017 mid. That's not like a pretty early time, and we got it running, and they delivered a model. And that became a big thing in the company. It's like, oh my God, now 2 of them did it. So, so the third one came on, and the fourth one came. And remember, this was something that, again, we did it in 2 months. So it's still a POC at some level, but we had built it like a proper service. We kind of built it in a way that we know how to build services. So it was still written in Go and so on. And so we were scaling it.
Was the reason for that to keep it close to Kubernetes? Was there why Go?
No, Go was the supported language. Go and Python were the options at Lyft actually only.
Oh, okay.
Just happened to choose Go at that point.
It's a good language.
Yeah, and we were like, we can't write this in Python. I don't want to spend like 10 times the money to run it to then actually, when they add in the actual workloads, because we wanted to do, more concurrency and so on.
Yeah, exactly. So, which Python is not the greatest at. Yeah, hard. The GIL, right?
We were not doing machine learning. We were doing the infrastructure, right? So there was a difference between those. The SDK layer was still in Python because that's what the users wanted, but the backend was all in Go. And we continued on, and this was 2017. We reached in 2018 probably. We now at this point we had about 200 users using, or 150 users using it at Lyft. And we started thinking, okay, this POC is going to break at some point. Let's make sure now that we have proven, right? We took 1, Airflow, we made it work. We took 2, we made it work, and we saw that there is demand. So there's a market fit. So then let's actually really invest a little bit in this and see what can we build? And so that's when I wrote the second paper that said, okay, with Kubernetes evolving, we took a bet saying that Kubernetes is going to be big in 2020, 2021.
Nice.
Right? And this is 2017 or 2018, early Jan, I think. And I wrote a paper that showed how you could do this with Kubernetes. And this time it's like nobody's writing operators, nobody's writing CRD stuff. Like, this is very early.
Yeah, wow.
And
so there was not really much community involved in this at this point either, right?
No, it's a big bet. It's just a bold bet that on paper. Wow. Right? Bets can be taken on paper as much as you want. There's no one person's brain is involved. That's it, right? So and we wrote that and we shared it again. I think the great part was this was like, you know what? If you can find time from supporting this other thing, you can build it.
Love that.
And the way we had done it is, it was interesting. We realized our components were right because it worked. Yeah, there were a lot of pain in the beginning, but once it became stable, we just continued to run. There were a lot of inefficiencies and things like that, but it continued to run without causing a lot of pages, and kept on supporting critical use cases, like things running every 10 minutes and so on, that actually drove the business. So we got some time, we built we started building. But during that time, we got contacted by other companies like Netflix and Airbnb and so on. We discussed ideas. We shared what we are doing, what they were doing, and so on. I think Metaflow didn't exist at that point, or it did in some other form, I think. And then we also talked to Google before Kubeflow. I think Kubeflow, they had just put like a TensorFlow operator out or something. And then they reached out to us and we were like, yeah, this is the design that we are thinking of building. And they kind of, put this idea in us that maybe we should open source it. And that's how, but we are like, if we decide to open source, it will take a while because we'll build it, we'll test it internally, right? We'll really battle test it and then we'll open source it. And somehow that didn't probably resonate well with them, or what, I don't know what happened. They decided to go their own way. It's kind of similar stuff though. Like Kubeflow is very similar. Kubeflow Pipelines is the project. Pretty similar to Flyte in some aspects. But that's great. Like eventually they could start sharing the ecosystem, which is amazing. And we decided to go on our own and continue building because we were building, and we had customers that we had to make sure. We couldn't just take something from open source and drop it in there and say like, yeah, now use this. Okay, it's breaking all the time without me understanding anything. Yeah, exactly. And so we didn't know that they were actually building it till like a year later. Well, that's when we came to know that they were building something. And by that time, we had heavily invested in Flyte on Kubernetes, and we had it like almost running it in production. And so we started doing the migration of internal, and we wanted to make that painless, so the interface and everything was the same. And that's when Flyte 2 internally. That's why internally, if you talk to anybody, they're like, "Oh yeah, Flyte 2, I use it." Is what Flyte in the open source community is. It's the third iteration of Flyte. And when we were doing this, we realized, oh, you need to have components that you can deploy easily. You don't want to break users when you deploy. They hate it, right? Because it's a serverless system. For them, it's like, you should never be deploying anything.
It should just work.
It should just work, right? And it's completely right. Users are always right. So it should work. But we needed to deploy and sometimes try out alpha beta features. So we made it completely componentized, and we can deploy to one cluster, make sure everything bakes, and then we move out to other clusters. We have tiers of service and so on. So we built it like that. Second thing, we realized that nobody's ever happy with whatever you do at a platform level. So you have to give them like the hooks to explore, extend, do whatever they feel like. And so extensibility is like a core thing of Flyte. So you can put Databricks, or you can put Kubernetes, or you can use SageMaker, or you can use whatever you want and extend it the way you want. But we realized that extensions, they have to go through some rigorous testing, because they make, they're cool to add extensibility, but the moment you add it, you lose potentially affect stability. So that's why we added extensibility in 2 layers. Users, you can add your extensions, don't have to share it with anybody. If you want to share it, it's libraries, we don't take care of it. But if we own it, we will manage it, we'll carry the pager for it. So you can extend the backend. So Flyte is extensible in the backend. So that's where you teach it how to talk to Databricks once. Then it will just work with Databricks, and it will be secure and guaranteed, and no resources used, because only the engine talks to Databricks. And I guess I answered that question. That we're basically, through this process, we learned a lot of things, and we actually tried to attack those problems, only the things that affected our users. And I think now we are seeing some other things affect our users, and those are the other new problems that we're trying to solve. So the philosophy of the team is that we solve problems that affect the users first, not just because we think it's cool.
It makes total sense. You were kind of organically building something to meet these demands, right? And I'm just taking note, you had a lot of complex data dependencies. You need to orchestrate a compute on demand, should be just kind of easy to use. You wanted to promote reuse and sharing, right? Composability. But then this open source element comes in, and then there's a lot of other challenges that kind of inform that, right? And I'm sure, did you guys learn from the community as well, based off how other people are using that? Did that give you ideas to say, oh, you know what? That's a good idea. We were kind of trying to solve that in this way, but we kind of like that better. Let's utilize that. Does it work like that, or is it? I have no clue, actually. That's why I'm curious. Like, what does that dynamic look like?
Yeah, it's this is my first open source project. I would say, our first rodeo. So it's humbling, right? The experience is just humbling. It's just, I am so grateful
Awesome.
to everybody who's contributing anything to us. A simple project that I started some time ago, like literally in a garage, right? There's so much learning. Like, I think every day, for example, we work with Spotify, and they are like, hey, by the way, we love your shareability concept, but what happens when and so the way they want to do it is they want to have platform build a bunch of tasks like these. So Flyte has this concept of tasks and workflows.
Mhm.
Tasks is like the smallest indivisible
Individual
part. It
component.
can be, yeah, it can be an arbitrarily complex thing like a Spark job, or it could be a query, or it could be a Python job, right?
Could it be
Uh,
another workflow itself? Could you have like
yep,
an Airflow
yep.
subdax? Okay.
Yeah, it can be workflow within workflow. There are also dynamic workflows, right? There are like all kinds of things. There's dynamism into Flyte. So what they wanted to do was, like, the platform team wants to provide like 10 hosted, uh, 10 pre-built components ready to go, right? So if I am a tag writer or a workflow writer, a pipeline writer, I just go and use one of their components, add my other components to it, and boom, everything works. Now the problem that happens is and this is called shareability. This is a Flyte native construct. You update, like, so the platform now wants to update the version of the workflow, and they want to change it in a way that the schema or the interface of that task changes. And the interface here is like, I take two integers today and produce one integer, like I'm summing. Oh, I want to take one integer and one float and sum the float value. And that's a change in the interface, right? A construct. Today we don't have schema evolution within
Okay.
Flyte, and so we
Okay.
are going to support that soon. Like, that just came from them, and it's just pretty. Was like, yeah, I don't know how we missed it, but yeah, we missed it.
I mean, but that makes sense though, right? You guys can't think of everything, and
It
that's
just
one of the
cannot,
things.
right?
Yeah, that's one of the things I like about just community things is that you actually can solve maybe problems that weren't maybe are not feasible by one team, one company, but with the collaboration of a lot of people can actually be possible or at least feasible.
Yeah, and I'm actually thinking that Flyte is impossible to build without a community. Like, a product like Flyte is so vast and big in ambition that the number of people you throw at it is less, however many it is. And if there is a community and all of them think alike and are share the passion to build and solve, like, and what we want to solve, to be honest, as a community, is like, make it easy for anybody who's writing any sort of software anywhere in the world, um, hopefully in the data and ML space, to not think about infrastructure ever again, right?
Oh, nice.
That's like the aim and the mission of Flyte. And it's not easy. We cannot do that.
No, yeah, very
Like,
hard.
and then secondly is like, they should be able to share it. Like, a person sitting in India somewhere should be able to write like a crazy algorithm tomorrow and put a button, and it's available to Spotify and Lyft and everybody of the world to use. And probably he gets comment, he gets money for it, maybe, right? That would be
That's
amazing.
awesome. Yeah, yeah.
Yeah.
A lot of things could come out of something like this. And before we get into some of the key features, I would love to cover them. One question I have is like not a question, but something that we've been talking about outside around Qflow, but because it was kind of formed with different companies kind of working on a specific subset of the problem. Some places got more love than others, and right now there's a criticism that there's a lack of cohesion, among these things. But it seems like with you guys, at least how Flyte was created, is you were focused on a specific subset of that, right? The pipelining workflows, and then little
Yep.
by little, it kind of organically grew. How did you manage cohesion with extensibility, if that makes sense, with the community? Because I'm sure there's some maybe some trade-offs there, right?
Excellent question. I think, and this is the real differentiator between Flyte and, let's say, Qflow, because Qflow is not Flyte. Qflow is an umbrella project in my head,
Yeah, it's a
which
whole
does a
suite
lot
of
of different
things.
things. Yeah, and Flyte is a specific, dedicated solution to one problem, that is orchestration. Right? Does it do serving? No, there is no serving. Does it do notebook servers today? No, it does. There is no way to host notebooks. You bring your own notebooks, and we will execute them and do things with it. But there is no notebook system. Does it do tracking? Yes, it does. But whatever executes in it. But does it offer a library to track like arbitrary things that are running somewhere? No. And for that, we should use some pieces in the community. So the way we have done is what we did is we actually looked at the problem and we just chopped and said, no, we will not do this. We will not do this. We will not do this because we cannot, right? This problem itself is so big. Let's just solve this and, dedicate our energy towards it. Let's make it the best that it can be so that the users are happy when they're using it. And then when the time is right, we'll integrate with the right pieces. Like, for example, we integrate great with all of the Kubeflow operators, right? Because that's like amazing. And we actually are able to build a nicer interface on top for the users. But eventually, if Kubeflow serving catches on, we will integrate great with them. Otherwise, we can use SageMaker serving. Otherwise, we can use SageMaker notebooks. Right now, it's an open world in that way.
I think it's important that you guys did consider some things out of scope, right? Like, this is cool, but like we need to focus our energy where it makes the most sense for us, right? And
exactly.
And I think that may be a challenge that a lot of like organizations trying to kind of work in this space. They try to do it all, but I'm not sure if that's like the best way to go about it, man. Maybe collaboration is actually the way to go and be open to extend your system.
Yeah, if you look at this market in general, just for machine learning ops and like the infrastructure, it's huge. If there is one company trying to do it all and that's like a 4-people team somewhere, it's not going to happen, right? And that's the honest opinion. It has to be collaborative. Like, I love what some people are doing, like weights and bias guys, and like these all kinds of people are doing like all kinds of cool stuff. I don't think I can do all of that, right? I don't even know everything, and I'm pretty dumb in that way. So let me do what I can help with. So yeah.
That's
And
awesome.
if any of those guys reach out to me and let's say like for example, Superconductive, like the Great Expectations guys, awesome folks, do great stuff with data quality. I think we can bring data quality to not only ML and data at the orchestration layer, and that's what we're working on. We should be hopefully delivering that at some point, and that's how we think about the problem.
Sweet.
Yeah,
That's
so
awesome.
that's kind of leading into one of the other questions that I had about these future initiatives. And I saw one on I think it was the GitHub page that you have, and it was something around reactive pipelines.
Yes.
Can you break down what that is?
Oh, yeah, this has been a long, this is one of the cool things that users kind of want, but they don't really express it that way, right? And as a team, we have seen this multiple times, but we don't think from the pure infrastructure point of view, we are ready to build that. Now, I think we're getting close to it. And I think when we build it, if you do it right, it can change the way we build things. And I'll give you an example. I don't know if you guys ever use Airflow.
I have, yeah.
Okay, so do you know the sensor operator in Airflow?
No, I don't.
Okay,
there's so many operators.
Yeah, there's a concept of sensor. What that means is you basically tell it, go look for this partition or go look for this S3 file. When that file exists, continue running the DAG. Simple. Very simple in idea, but very flawed in implementation. And the reason is, by definition, a DAG runs at a time. And so that, yeah, you have to put this at the beginning of the DAG execution. And so let's say a file is, that means you're actually presupposing that the file is supposed to appear at 12 a.m. tonight. And how is that a contract? Like, that's like, why is time a part of the contract? File supposed to appear is a good enough contract. Putting time bounds on it actually causes further challenges because now you have to put a timeout. You cannot say that the file will appear forever sometime, right? It'll appear within the 1 hour after 12. Again, flawed, right? What if the upstreams are broken and things are like that? So the way I think about this is that this is a natural reaction. The pipeline essentially wants to run once that file appears. And that's like the reaction that you want to react to in the pipeline. And this is what a reactive pipeline is. Like, you want to say that these are the events in the world that I care about. Once those happen, I want to execute something or set up
It
things.
sounds like an event-based architecture, right? Like,
but a distributed architecture, right? Not streaming. This is like event-based things happening, and they are getting triggered by a central hub somehow. And because of serverless, this is possible because you have the definition of everything. We know what the requirements are. The data appears. Now let me trigger that. And I'll give you an example. In teams, this happens a lot, right? And this is what in microservices, there are multiple teams, they share contracts and you talk with them. But in pipeline, like teams, there are multiple teams that write pipelines and they build artifacts. And now you're sharing and you want to link by that artifact. And so there's nothing in the world today that actually ties them together. And I
Wow,
think
that's so cool.
How do you?
So
I was
that's-
just gonna ask. Like, I know, like, there's things like PubSub where they decouple the publisher and the subscriber, so you don't have some of those complications. How do you guys deal with that? Or is because it's not for streaming, that really isn't so much of a problem?
no, PubSub would be a technology used to build this, right?
Oh,
But
okay, okay.
it's not the higher level construct that the user sees, right? From the user's point of view, they're like, I'm producing artifact A, and the other guy doesn't say I'm subscribing to some channel or something. He says I'm subscribing to this artifact A, right? That's it, right? This is the idea. And then the backend infrastructure of how the PubSub channel was brought up, how the data was created, when did it run, how did it run, what happens in failure scenarios, what happens if the upstream was rerun and had an error, and all that stuff is what we think about abstracting. Because I think that's a
Nice.
piece that's complicated enough for organizational growth. And so like the same way we want to, like, a one team builds an artifact, we also think the other aspect is you may want to rebuild that artifact so you can share tasks, which is supported by Flyte today, but we don't allow you to subscribe to an artifact. And so that's like the other bit. And the way we think about it is based on a simple example. Another example is if one pipeline fails, you may want to trigger an alternate pipeline. That's another reaction.
Nice.
So those are the types of reactions we want to capture and build like a central way to visualize these reactions.
So there's a UI that users interact with for Flyte?
Yep, there is.
Nice.
So the UI is driven on our backend service. There's just one service. You work with one service. It's a REST gRPC service. Prefer your choose your language. I don't want to take a side between REST and gRPC battle. You can choose whatever you feel like.
We have both.
Yeah, exactly. And there's a cool open source project that does gRPC to REST gateway conversion. That's what we use. It works beautifully. Thank you, whoever. I forgot the name of the author. It's amazing. Yeah, so you just interact with that. And the UI that we have today, Flyte Console, it's actually just a subset of all the features that are available in Flyte, because the UI takes longer to build, right? And it's built on top of this REST gRPC API. So anybody can bring their own UI. And there are teams within Lyft who build their own UIs on top of Flyte.
Okay.
And how does the installation process look like? Is it with Helm install, and is it different when you're on-prem or you're in the cloud?
Excellent question. I think this is one of the things that I've been learning after going into open source, right? At Lyft, this is not a challenge because it's already run. It's there and people use it. It's hosted on some endpoint, flyte.lyft.net, available. Outside, you have to start off by installing it. And so we are actually trying to absolutely work on this problem and make this as smooth as possible. So Flyte needs today 3 things. It needs a Kubernetes cluster somewhere. Could be on your laptop, could be in the cloud, could be wherever. It needs a blob store, like something like S3, GCS, Minio. Doesn't matter if it's on-prem or whatever, right? Like, ideally, we are built for cloud because those are the things. And the third thing it needs is a Postgres database. If you give it these 3 things, it's possible to bring up Flyte. And I realize that even bringing up these 3 things is a challenge because like in AWS, you can bring up Aurora or whatever, Postgres pretty quickly. In Google, you can use Cloud SQL, but other places it's a challenge. And so I'm not talking about the cloud, but like on-prem, for example. So we want to simplify that entire thing. And the way we are thinking about it is today you have FlyteKit, which is the Python library, and there's FlyteKit Java, which is contributed by Spotify, which is the Java library. What those do is you just specify tasks and workflows in them, and then they compile into a representation into the Flyte Cloud, Flyte admin service. And then from there, you can execute them. We want to get to a point where FlyteKit and FlyteKit Java are completely self-sufficient, and they are good enough for you to get a win under your belt, right? Only then should you invest in the cloud part of it. yeah, and so that's the part that we're working on actively, like better tutorials, understanding. We don't
Nice.
use
Yeah.
Helm, we use Customize, but we are
Okay.
also exploring Helm plus Customize. It's a
Oh,
hybrid
nice.
option that
Yeah.
people are nowadays trying.
I think, yeah, those are the type of questions that like an SRE would ask, like, hey, how do I install this? How do I deploy this? And that if there's documentation, that really does help, because most of the questions that I see like on the Qflow are around installation and setup. And I have actually set up my own Qflow deployment on GCP, and it is not easy. There's also, and that's like where it's made for, right? They've made it super easy,
Yeah.
but there's all sorts of things that come up. And I know at Benevolent, we've done it on AWS. There's definitely been some challenges there, but yeah, it's like it's usually like a blocker for a lot of people just to even get it up and running, you know.
Right. And we are trying to make it simple, but yeah, we have a customized base and GCP and EKS specialization, but you still have to modify some configuration. And that's where we think help can help us. Or we actually have a very cool configuration tool written in Golang. We should eventually, and it's contributed, it's part of Flyte STD lib. But yeah, it's pretty cool. You guys, like, I think I would recommend the users to look at it.
What's it called?
So
Flyte STD lib is like all of the core, many cool libraries that we use within Flyte or we build for Flyte are all open source, and they're all battle tested and production ready, right? So if
Nice.
you think, oh, I want a hash map, or sorry, a set implementation that's battle tested, it's there in Flyte STD. Do you want some sort of future implementation that's battle tested, it's already there, because Go doesn't have all of this today, right? And
Okay, yeah,
through
yeah.
our 4 years, we had to build some of these things, and they're ready to go. They're independent.
that's an
nothing,
awesome
nothing to do
resource.
with Flyte. Yeah.
Yeah,
That
we're
is
gonna
so cool. Yeah.
check that, guys.
We're
Check
going to
that
link
out.
to that. Yep. Yeah. We'll put a link to that one for sure, because
Oh,
that
thank you.
sounds incredible. Can we talk a bit about the architecture and how that looks? I know we saw a quick diagram on some blog, but I'd love to hear from your mouth what that looks like and how it looks.
Yeah, I think it's a sad part that our documentation needs to improve. We are working on it. That's what I will preface it with. It's like a continuous work, right? Our documentation. But the architecture is essentially today, right? I will talk about today. So if you are a new company who's trying to install Flyte, the architecture is this, where you install 5 components, and they are all part of one customize. Those components are,
Okay.
I start with the client first. So you pip install Flyte Kit into your virtual environment. That's how you get the SDK. Think about AWS SDK or Google SDK, right? Google Cloud SDK, same thing. It's just a very lightweight wrapper around the backend services. The backend service, the entry point for the user is Flyte Admin. Flyte Admin is essentially the REST gRPC interface. It talks with the database, stores the records, gives you errors, shows you UI, doesn't show you the UI, but feeds the UI, feeds the CLI, feeds everything. Then you may have a Flyte console, which is the UI component that comes with Flyte. And if you choose to use it, then it runs using Flyte Admin. So they need to talk to each other.
Okay.
Once you have Flyte Admin, so it's like the inventory system. Flyte Admin just stores the inventory of the entire pipelines and
Like
their
this,
execution history and
like the
tracking history.
state, what's been going on type of thing.
Yeah, like historical stuff, like this ran, this was the output produced, this was the input given, blah blah blah, and you can trigger new things with it. And we go through this cool phase called as a compilation. So we do the Flyte Admin compiles your workflows. So when you create a workflow, you could create workflows from shared tasks that somebody else has written,
And just
and
compile them
somebody.
at compilation time.
Yeah, so we
Oh,
compile
okay.
them kind of. Why do we do that is we wanted to make sure that the users find errors in their pipelines early, right? And
Very
the
good.
way do we do this? That's why we have a type system. We have parameters, inputs and outputs, and those are typed, strongly typed. So when
Yeah,
you put together
nice.
a pipeline, it will tell you that this pipeline most likely works. Now you can still have runtime failures. You may expect an int and internally you're using it like a string. Sorry, that'll fail. But at least, by construction, you're saying that it looks good. All right, so now that's at admin. At some point, the user goes to console or to Flyte CLI and says, let me run it. Let me run a workflow. When the workflow run happens, that's when the compiled workflow gets converted to a Kubernetes CRD. And that's where the fourth component comes in. That's called Flyte Propeller.
Ah, yeah.
Flyte
Looking at it
Propeller
now.
it's a Kubernetes operator. It's a very high performance operator that we have written. It runs like probably 2000 workflows concurrently on one process. And because it's using the Go concurrency model. So
Nice.
and it's easily shardable. You can add as many versions of it. So it's stateless, shardable, only does one thing, executes
That's
the
so
workflow.
cool.
But that's
Love
the
that.
engine, right? That's the brain, right? That like takes in everything, produces the output, calls the DAG, and so on. And you can have plugins in them, and those are Flyte plugins, and you plug them into Propeller, and Propeller propels them, right? That's the idea.
I like that. I like that.
And then the last bit is data catalog. It is an independent island that sits separately because whenever Flyte Propeller runs something, it records it in data catalog. And when it's recording, it uses that recorded information to cache things. Like, for example, if it sees the same execution happening again, it just reuses the results from the previous run.
That's so
And that
helpful. So helpful.
it does. Like, for example, in ETLs, right, you have a top upstream break, let's say, but that only causes one task to invalidate. In the bottom, some downstream job, you just run the top, fix it, run it, only that portion will run again. And this saves thousands to millions of dollars.
Yeah,
No,
it does.
dollars too, right?
Yeah.
So that's one of the reasons why we built it. But the side effect of that is that it actually is now automatically tracking all the lineage. Who used this data? Who generated this data? Blah, blah, blah. And there is no cool UI today in front of it. Flyte console just like gives you a link of what cached the data from where to where you go and so on, like who generated the data. But we eventually want to build like an entire data catalog explorer that shows you the entire data that was generated by anywhere in the system and how it was used. It has tags, it has searchability and so on built into it. So those are the 5 components.
That sounds so awesome. And it looks like there's some blogs that have an out of date version of this, but it looks like overall most of it's pretty much the same. Like I see some stuff here, like what is it called? Like what's the Flyte Propeller that's been around for a while. I see here that interacts with operators and other external services.
That's the Flyte plugins. Those are plugins, right? So you can add a plugin for any operator on Kubernetes. We have a simple API, and the GitHub repo for that is Flyte plugins. It has an API that says, "Oh, here's an operator like TF operator. Let me teach Flyte how to talk to TF operator." So it's like a simple way, and then it becomes a Python interface and a Java interface to talk to the TF operator. And it can the same place you'll write how to talk to Databricks or EMR, whatever it is, like data flow.
So cool, man.
And so one of the things we did is actually the reason why we say we are not fully Kubernetes native is because we support multiple Kubernetes clusters out of the box. And we had to do it for Lyft. If you know the numbers, right? 1 million pipelines and 40 million containers, it doesn't work on one Kubernetes cluster. So Flyte admin, we just take it out of the Kubernetes cluster. And this is the advanced. I don't think most users need to do it, but you can take it out of the Kubernetes cluster, spin up 4 Kubernetes clusters, and Flyte admin will talk to them and schedule everything and manage them for you. And that's the other part, like a multi-Kubernetes cluster ready.
Awesome, man. This has been go ahead, Demetrius.
I just love this idea that you said before about the whole goal of Flyte is so that anybody in data science or working on machine learning doesn't have to think about infrastructure. I think that is such a key point and something that we've been seeing a lot of people talking about, like, should a data scientist learn Kubernetes? And the hard answer that I feel like we've seen is not really, unless you want to like spend your time going on that, learning that new skill. But do you feel like you'll prove value or you'll provide that same amount of value as you would if you were doing what you are good at as a data scientist? So that whole thing for me is, it's awesome to see. I love what you're doing.
Oh, thank you. Yeah, I actually think that the expectation is unrealistic. like we are expecting them to be PhDs in machine learning and then PhDs in distributed systems. That's not going to happen.
Yeah, it's
It's
hard.
hard skills, right? Like, and some of them are battle learned skills, right? Especially distributed systems, we've learned them.
Yeah, I gotta say
By
for
failing.
me, yeah, but exactly, that's how I learned. I just got thrown into the fire and just like had to like deal with these challenges as they came along. But I never was like formally trained on them. It was just more like, oh, you know what? Let me read a book to better understand what I'm actually dealing with in my real life, work. And little by little, you start learning these things. But it's very difficult to expect someone to have all of them out of the box. Like I think what's a better thing to look for is someone that can quickly pick up new skills. Someone that's if you have that, I think you'll be fine with a lot of the complexity that we deal with. But to have this sort of expectation that they have to know all that, manage all that end to end, I mean, that's a team that you just described.
Yeah, and yeah, today that's one of the things that there is a team at Lyft that runs the infrastructure, and that's the reality of it. In most organizations, that will happen. Expecting your data scientist to also double up as the infrastructure engineer is probably going to cause a lot of productivity problems, right? At some point, I'm not saying that is not the way to do it. You can when you're a small team, and that's one of the things that I am it's very dear to my heart, where I want to focus on and improve the getting started experience for the 5-person team. How do I make the 5-person team really, really productive on day one? It's a challenge. It's hard. I won't lie that I have not solved it completely.
So before we wrap up, there was something you said that I just wanted to touch on because I think it's a really cool idea around. It was like you were talking about how somebody anywhere could make something and have it like on a marketplace. Was that your vision
Yeah.
for Lyft as we move forward?
Not
I mean,
Lyft,
sorry,
Flyte.
as Flyte. Sorry.
Yeah, Lyft is a marketplace, but yeah, that's a different
Yeah, they
marketplace.
already got that handled. Sorry.
Yeah, I have a anecdote or a corollary for this. Like, I think we write we write code every day. We're all engineers. How often do we write a sorting algorithm besides during interviews?
Never. I
Never.
just out of the box. Yeah.
Why do we do that for all of these weird pipeline distributed things all the time? All the time we're doing that. And I know people will disagree that we have UDFs and no, we still do the same thing. We are basically sometimes just joining 3 things, or you're like, transforming one, like in mapping case of that long to like a micro degree and then transposing them. And that is a challenge. That's the challenge I want to hopefully, I'm not saying I will be able to, but I would love to in some way make it easier, that once a problem is solved, let's just share it. Let's just like GitHub. When I was an engineer earlier on, or I'm still an engineer, but when I was in the earlier days, I did not have access to GitHub. And I feel that that's just so cool today. It's just that you go, you search, you can take open source projects, you can contribute to them. It's just amazing. And I want to I think we can do that for code with infrastructure together. And that would be an aim and a mission.
Love that. That's such a great note to end. Well, guys, we want to thank you for taking the time to listen to this awesome conversation. Please check out Lyft, check out Ketan. Where's the best place to reach out to you? Would it be LinkedIn, Twitter?
LinkedIn, I am pretty Twitters too. I'm actually not as active on Twitter, but I've gotten some comments on that I should be. So I am. Please follow me on Twitter or send me messages. And then
Flyte
worst
has
case, if you have lots of complaints, I love to hear complaints about Flyte. I would love to
Nice.
answer all of your questions.
Nice.
there is a Flyte community, right? You have a whole Slack workspace and all of that, right?
Yeah, we have a free Slack workspace. It rolls over after 10,000 messages, but yeah, please join over there. Would love to. Yeah, give me the feedback. Dish it out to me. I would love it.
Excellent. Well, check
Awesome.
out Flyte, guys. It has a lot of awesome features. I'm just going to throw out some of them just so you guys keep them at the back of your mind. It's multi-tenant, it's hosted, it's serverless, it's parameterized. You get your data lineage, you get your caching, you get your versioning, you get your you get your modularity, and it's loosely coupled, guys. So check it out, and also check out my man Ketan. He's cool as hell. I really enjoyed this. And we just want to thank you so much for making this time to speak with us in the community. And we look forward to hearing more from you in the future, hopefully.
Absolutely, guys. I had a blast. Thank you for having me. And yeah, one thing I'll add to what David, it has a lot of things, but it is not a machine learning platform. It doesn't have
Nice.
serving. It doesn't have,
That's
it's
right.
not, right? So don't go with the wrong expectations.
Mm.
And I would love to answer any other questions.
Awesome, man. Thank you so much. We'll see you all later.
Bye, guys.
Bye.